Chemical energy is energy that is stored or released due to the formation and breaking of chemical bonds during chemical reactions. So remember what I said earlier, atoms can sometimes be bonded to each other, stuck together really, really strongly. So this was my example of water. Two hydrogen atoms, H2, one oxygen atom, H2O, stuck to each other through strong chemical bonds. We will talk about these strong chemical bonds and what they are composed of, where they come from. We'll talk about that in a later unit. But for now, all you need to know is that a chemical bond is what holds atoms together to make compounds, to make molecules like water. So right there is a strong chemical bond. I'm using the word strong because they are strong, and these bonds are not easily broken. But they can be broken sometimes. If you zap a whole bunch of water with electricity, you might be able to break these bonds, for example. Let's look at this little diagram over here. This shows a chemical reaction. A chemical reaction is when you start with a set of substances. So this is a substance called methane, CH4, and this is oxygen, O2. You start with one set of substances and you end up with another set of substances. Looks like I have CO2. Does anyone know what that's called? Carbon dioxide. And then I have H2O, water. Looks like I have ended up with two of those. Looks like I started with two oxygen molecules. You don't need to know what any of this means. This is just an example. You guys will be able to talk about chemical reactions in a later unit. But chemical energy, all you need to know right now is that if you start with some substances, you're going to end with different substances. That's called a chemical reaction. And what's actually happening is that each of these bonds, each of these chemical bonds in the old stuff are getting broken. So these bonds are breaking. And that always requires the system to absorb energy. The system has to take in energy. So the energy of the whole system goes up, and you can see that all the bonds have been broken. And then when I form new bonds to make the new stuff, the atoms rearrange. So this carbon here, which was stuck together with four hydrogens, is now going to get stuck to two oxygen atoms. The atoms are rearranging themselves in this chemical reaction. Whenever you form these new bonds, energy is released from the system, so energy can go out of the system. So if bonds break, energy goes in to the system. When bonds are formed, energy goes out. That's chemical energy. This is how batteries work through chemical reactions, able to release energy. This is how your body right now is being powered. Your body, the cells in your body, the mitochondria of your cells. The mitochondria is the powerhouse of the cell. The mitochondria are performing these chemical reactions to release energy as new bonds are formed and all this stuff. So chemical energy is a really, really important type of energy to our day-to-day lives, our daily functioning. So chemical energy is the energy change due to atoms being rearranged in a chemical reaction. Old bonds being broken, new bonds being formed. We get energy changes there, and we can use that energy to do something useful, like text a friend, or play the stupid game on your phone you like to play, or power your body, think and write and talk and move and run and things like this, power your muscles. So chemical energy is really important. Don't get bogged down in the details here. We will talk about all this later in more detail. Mechanical energy. Mechanical energy is the energy that is stored or released. So it's really energy that's due to the position, arrangement, and motion of objects in a system. Position, arrangement, and motion. Now, I don't want you to get confused about this. The objects we're talking about with mechanical energy tend to be big objects. By big, I mean that we're not talking about atoms and molecules like chemical energy. We're not talking about atoms or molecules or little tiny particles like thermal energy moving around. Technically speaking, thermal energy would be a type of kinetic energy. It's these little pieces moving. But when we are discussing mechanical energy, we're talking about large objects like this weight being pulled up by this man, or like a roller coaster um, moving down a hill. So we're looking at large objects. We're not studying atoms or particles anymore. So mechanical energy has different types. The first type is potential energy. You guys have heard this term before, I'm sure. Potential energy, you can just think of it as energy that has been stored up due to the position or arrangement of objects in the system. So it's stored energy that is stored. It has not been released yet. It has the potential to cause a change. Remember, energy is all about changes. It has a potential to cause a change, but that potential has not been released yet, so to speak. There are two types of potential energy. Potential mechanical energy, I want you to be aware of. The first one is called elastic. This has to do with objects that are able um, to be misshapen, I guess, that are able to be squished or stretched. So the typical example would be a string or a rubber band. So think about a spring or a rubber band. So think about this spring right here. It is resting. This is how long it would normally be. There's no outside forces acting on it. So we would call that static, or we might say that the spring is at equilibrium. And if the spring is at equilibrium right now, its potential energy, its elastic energy, I would say is zero. But I can store energy into it if I take the spring and compress it down. If I squeeze it and I compress it, I cause the spring to shorten. It now has some potential energy. I have placed energy into the spring. Energy has come out of my body and has gone into the spring. I have stored energy in that spring. The same thing will happen if I stretch the spring out. I have caused energy to leave my body, leave my muscles, and enter the spring as I stretch it. So a compressed or a stretched spring, or we could say a rubber band, has elastic potential energy. Think about it. What's going to happen if you let this spring go? Well, it's gonna move, right? It's gonna move back to its equilibrium. It's going to start bouncing around. So I store energy when I stretch it, and then I can release that energy when I let it go. Same thing with the compressed spring. Another type of potential energy is called gravitational potential. This is due to objects being lifted off of the ground. So again, energy due to the position and arrangement of object in the system. So the Earth is down here. The Earth is exerting a gravitational force, and if I lift an object off the ground to a certain height, I have just stored into it a type of potential energy, just like the spring earlier. When I compressed or stretched the spring away from equilibrium, I have stored energy into it and now has the potential to cause a change. This definitely has a potential to cause a change. If I let the string go, what's going to happen? Yeah, it's going to start falling and getting faster and faster, accelerating due to the influence of gravity, right? So gravitational potential energy is due to objects that are lifted up off the ground. We can kind of think about how much energy there might be. So just imagine this, the more you compress or the more you stretch the spring, I think it makes pretty good common sense, the more potential energy you have stored into it, right? So the amount of potential energy in an elastic system really depends on how much it has been compressed or how much it has been stressed, how far away from its equilibrium, its normal chill zone, how far away from that normal chill zone you have taken it. Same exact thing with gravitational potential. Where does this weight want to be? When is it going to be chilled out? Yeah, when it's on the floor. So the further you move it up, away from ground level, the more potential energy it's going to have. So both of these depend on something like distance. How far have you stretched or compressed the spring? How high up? How far have you moved the mass? For gravitational potential too, think about this. What's going to have more potential, more ability, more stored up capacity to cause a change? A large, massive object like that off the ground, or a little massive object like this off the ground? Which one would you rather stand under? I'd rather stand under this one. It's not going to hurt me as much. This guy right here is storing a whole lot more potential to cause a change. So we can see that not only does gravitational potential depend on how high up the object is, but it also depends on the mass of the object, right? So the more massive the object, the more potential energy, the more gravitational potential energy it is storing. So that's something to keep in mind. We will review that in more detail later on. And there's also kinetic energy. This is the energy of things that are moving. So again, mechanical energy is all about the motion, position arrangement, and motion of objects. Kinetic energy is the energy that a moving object possesses. This radical skateboarder flying down the hill. Once again, if I let go of the compressed or the stretched spring, what's going to happen? It's going to start moving, right? If I let go of this massive object, what's going to happen? It's going to start moving. So anything that's in motion has kinetic energy. Potential and kinetic energy, these are the two main types that we're going to kind of start our study of energy with. And we call them mechanical energy, mechanical dealing with large objects.